This is a key to the factoring worksheet on topic 8, part A, and that was the one dealing with the difference or sum of two squares. So each of these will be a difference or sum of two squares. And it says if the polynomial cannot be factored, it says write prime. So make sure you use the word prime because that's what the directions state to do. So let's go ahead and look at number one. So in number one, we have x squared minus 49. And so remember when we talked about the difference of two squares, it will always look something like this. It will have some expression, some term squared minus another term squared. So each of these, if you do have the difference of two squares, you'll be able to write this expression as this. And so if I write this as, let's say, f and this l, so first and last, then you can factor the difference of two squares as f minus l times f plus l. And remember, you can always check yourself by foiling this out and seeing if you do get the original back. Okay, so if I look at number one, you'll notice that especially 49, you remember that 49 is a perfect square. So I can write 49 as 7 squared. And so that's what you see here. So I can write 49 as 7 squared, and obviously x squared I can write as x squared. So notice that this binomial I can write in this form, which now indicates that this right here, is the difference of two squares. And so therefore the answer is going to be x minus 7 times x plus 7. All right. Now again, if you have time, you can always check. So if you check this quickly, x minus 7 times x plus 7, by foiling, let's see what we get. We get x times x is x squared. The outer is a positive 7x. The inner is a negative 7x. And the last, a negative 7 times a positive 7, is a negative 49. And so remember, when you have the difference of two squares, see how right here the signs, everything looks almost identical except for the signs. So that means that when you do the outer and the inner, they will be opposites. They will be opposites. So that means that if you do have the difference of two squares, the outer and the inner will add to be 0, and you just have the first squared minus the last squared. All right, so this becomes x squared minus 49, which is what you wanted. So that was correct. All right, now number two. Number two, we have 64 minus x squared. Now, some students have a habit of wanting to put the variable first, but leave it like this, because if you put the variable, if you put this term first, then you have a negative x squared plus 64, and that confuses students. So leave it like this. So right away, you notice that this is the difference of two squares. So I can fill in this parentheses as 8 squared. So 8 times 8 is 64, and again this is x, so therefore I get 8 minus x times 8 plus x. And if you want to, you can go ahead and FOIL it out like we did here, and you will see that this is the binomial that we have here. Okay, number three, we have 36a squared minus 25. Now, before we go on, the first thing we should always do, and we did not do that in the first two, but the first thing we should always do is look to see if each of these polynomials has a GCF other than 1. And so in number 1, the GCF was 1. In number 2, the GCF is 1. And so is the GCF in number 3. So the GCF is 1. So if the GCF is not 1, something other than 1, then you would factor it out and go from there. But this right here is the difference of two squares, because I can write this as, so remember, you have the difference of two squares if you can fill in these parentheses. So 36a squared is 6a times itself, and then 25 is 5 times itself. And so therefore your answer is going to be 6a minus 5 times 6a plus 5. Okay, number 4. Number 4, we have 3x squared minus 12. All right, so again, remember we talked about you got to look for the GCF first. So the GCF is not 1 this time. The GCF is 3. And right away you knew that this right here, the way it is written, those two terms, that binomial, you cannot right away fill this in, because 12 is not a perfect square. So always look for GCF. So the GCF here is 3. So based on our previous lessons, I know that I can rewrite this then as 3 times x squared minus 4. Now, remember, you got to factor completely. So just because you factor out the GCF doesn't mean that that's your answer. Because notice, x squared minus 4, that is the difference of two squares. So I can go further with this. So this becomes x minus 2 times x plus 2, doesn't it? And so therefore this needs to go here. So your answer is going to be 3 times x minus 2 times x plus 2. All right, so let's look at number 5. Okay, so number 5, we have this for number 5. Number 5, we have, let me go ahead and move this over a little. All right, so number 5, we have 25 x squared plus 16. Now, notice that this right here is the sum of two squares. The sum of two squares. And the GCF is 1, okay? GCF is 1, but it is the sum of two squares, and we know the sum of two squares is prime. So right away you're going to say prime. You cannot factor the sum of two squares. So it is prime. Number 6, we have 81 minus 25x squared. So again, notice the GCF is 1. So I'm going to go ahead and see if this is the difference of two squares. So meaning that I can fill these in. So this is 9 and this is 5x, right? So 5x times 5x is 25x squared. 9 times 9 is 81. And so therefore you get 9 minus 5x times 9 plus 5x. Okay? And remember, always check. If you're not sure, if what you have is correct, check it. So FOIL it out. Let me go ahead and do this one. So 9 minus 5x times 9 plus 5x. And so we're going to FOIL. So 9 times 9 is 81. And remember the difference of two squares. See how these are almost, these two binomials are almost identical except for the signs? And that means that when you do the outer, 9 times 5x is 45x, a positive. And the inner, negative 5x times 9 is a negative 45x. These are opposites, so that means that when you add them up, when you add these up, you're going to get 0. And then a negative 5x times a positive 5x is a negative 25x squared. And so we get 81 minus 25x squared, and that's what you wanted. Okay, number 7. Number 7, we have x squared minus 16y squared. So again, the GCF is 1, and this one's easy because you can see that this is the difference of two squares. X squared is x times x. 16y squared is 4y times itself. And so therefore we get x minus 4y times x plus 4y. So very easy, isn't it? Okay, number 8, we have 100x squared minus 169y squared. 100x squared minus 169y squared. So the GCF is 1, and so this is the difference of two squares because you'll see that you will be able to fill these parentheses. So 100x squared, you all agree, is 10x times 10x, and then 169y squared is 13y times 13y. And so therefore this becomes 10x minus 13y times 10x plus 13y. Now notice, and I just wanted to show you, in all these cases I put the first binomial was a subtraction, and then the second was the addition. You do remember, right, that multiplication is commutative, so the order in which you multiply does not matter. So if you wanted to, you could have also said in all these cases, but since I'm on number 8, you could have also said 10x plus 13y times 10x minus 13y. Okay, so just keep that in mind. Okay, and then number 9, so we have 2 left. Number 9, we have this one. So we have 5x cubed minus 45x. So first of all, notice that 45 is not a perfect square, or 45x, right? And then this is x cubed, so that's not going to be a perfect square to begin with, and 5 definitely is not a perfect square either. So what you should notice also is that the GCF here is 5x, right? And so therefore I can factor out a 5x, and when I do that, I'm going to get 5x times x squared, because 5x times x squared is 5x cubed, minus 9. And I know that x squared minus 9, remember, always go further, don't stop there, because you got to factor completely. I know that x squared minus 9 is the difference of two squares, and I can factor that as x minus 3 times x plus 3. All right, and again, if you wanted to, you could have rewritten, put this binomial here instead of there. But always put the monomial factors first. So you're going to say 5x times x plus 3 times x minus 3. But again, always put the monomial factors first. So 5x in both cases are listed first. Those are your first factors. And then finally, number 10, you have x squared y squared minus 16. All right, so this one's easy as well in it, because you know, well, first of all, the GCF is 1, and you also know that 16 right away is 4 times 4, and x squared y squared I can write as xy times itself, right? And so therefore your answer is going to be xy minus 4 times xy plus 4, or remember, if you remember, multiplication is commutative, so you could have said xy plus 4 times xy minus 4. All right, and that is the key to um, topic 8, part A factoring worksheet.